Section 8.2, we will be looking at the law of sines, and this is a method to solve a triangle, not necessarily a right triangle, just any triangle. So in order to solve a triangle, you need to find all three sides and all three angles. So usually they're going to give you three of them, some combination of sides and angles, and you will have to find the other three. So law of sines is a fairly simple formula. We're going to do sine of angle A over side A equals sine of angle B over side B, which equals sine of angle C over side C. So this particular formula can be proven using the area of a triangle, but I'm going to skip over that for now, given the circumstances. And so what we're going to do is we're just going to take two of these proportions and we're going to set them equal to each other. So any two will give us a ratio that we can cross multiply and solve. So like I said, we can solve three different triangles on this. This one is used first to solve side angle formulas, or side angle triangles rather, and also angle side angle. All right, so in these two, notice that we're going to be given two angles. And so in a triangle, when there's only three angles, and you're given two, the third angle is a given, right? We can just subtract from 180 to find that third angle. So I'm just going to draw a random triangle here. And so how do we know whether it's a side angle? I'm going to start over here on the right-hand side. And if I go clockwise, and say we know this side, then the angle means we know the next immediate angle and the next immediate angle after that. Okay, so the ones I've marked are the ones we know. All right, side angle. Notice in a side angle, not only can we solve for that third angle very easily, but we have one of those proportions from law of sines that we can set up. Because, right, if I label these corners here, A, B, and C, we know angle B, and we know side A, and so we can set up the proportion here for A. And then we'd have to solve for little c here, the side opposite little c. So the angles are normally labeled with capital letters, and the sides opposite those angles are labeled with a lowercase letter. Okay, so this is what a side angle would look like. So if I wanted to kind of label what an side angle triangle looked like, I'm going to start with the top angle here. That means we need to know the next immediate side and the next immediate angle when traveling clockwise. So if I start here, the next immediate side is here, and the next immediate angle is here. Okay, so this is our angle, side, angle. Right? So if I were to label these A, B, and C, okay, and then the side opposite angle A is little a, the side opposite angle B is little b, and the side opposite angle C is little c, right? We're not given one of these proportions, but we can solve for angle A very easily, right, by subtracting from 180, because we know angle B and we know angle C. So you can solve for angle A, and then as soon as we have angle A, we have a proportion, okay, sine of angle A over little a, that we can use, and then we'll just solve for the other two sides using that proportion for A. Okay, so there's one more. Oh, and these ones only have one solution. And the reason why these only have one solution is because two of the angles are given in each case. So when we have two of the angles given, there's only one value left that can complete this triangle. So these ones are going to have only one solution. So the other one that we use law of sines to solve is side-side angle. Right. So notice that in a side-side angle, we're only given one angle, so there's multiple combinations for the other two angles. And so these side-side angle solutions, or triangles, may have actually 0 solutions, 1 solution, or even 2 solutions. And so we're going to look at quite a few of these types so that you can get used to determining whether they have 0, 1, or 2 solutions. So I'm just going to draw a random triangle, and I'm going to mark it according to side-side angles. So I'm going to start over here on the right again. So I know this side. So the next thing we know is the next side. So I have to skip over this angle, and we know this side. And the next we know is the next immediate angle after that. So we know this angle. So side, side, angle. Right? So as you can tell, we have a proportion set up here. So if I were to label these A, B, and C, right, we know little a, we know angle A, and so we can set up that proportion for sine A over A in order to solve the rest of this triangle. All right, so let's go ahead and do, I'm just going to do one example up here because these are pretty straightforward, right? Fairly simple. So the directions are going to say solve the triangle. And the given information is angle A is 37 degrees, angle C is 75 degrees, and little a is 11. Okay, so I'm just going to draw a random triangle here. Right. And I always label A, B, C, and then little a, little b, little c. Okay. So we know angle A to be 37 degrees. We know angle C to be 75 degrees. And we know little a to be 11 degrees. So this is a side angle angle. Right? Because if I start here, I know the side, and then the next immediate angle, and then the next immediate angle. So since we're given angle A and little a, I'm going to set up that proportion. And then I'm going to go ahead and solve for little c first. All right? Do it over here. I know I could find angle B rather quickly. I'll do it in a second. All right? So let's do sine of angle A, which is 37, divided by side A, which is 11. And then I'm going to set up the proportion for angle C and side C. So sine of angle C divided by side C here. Right. So in this ratio, we can solve for C if we cross multiply. So I'm going to get C times sine 37 equals 11 times sine of 75. And then solving for little c, I'll just divide both sides by sine 37. All right, so if you haven't figured out, we're going to be using our calculators pretty heavily here. So I'm going to take the time to plug this into my calculator. All right, so make sure you are in degree mode because we want our answers in degrees. And then just watch out for how many decimals they want. I'm probably going to be all over the board with how many decimals. But most of the time I just use 0, 1, or 2 decimals. All right, so let's do 11. Oops. This 11 times sine 75 really needs to be put in parentheses. So let me try that again. 11 sine 75 divided by sine 37. All right, so make sure you can plug these in and you're getting the same answer as myself. All right, so I get 17.655, so I'm going to go ahead and round that to 17.7, right? That's little c. So I'm going to label that. So now to solve this triangle, I need to find angle B and side B. So angle B is just a matter of subtracting from 180. All right, so B is 180 minus the other 2 angles given. Okay, so 180 minus 37 minus 75. I just punched that into the calculator real quick, and I'm getting 68. All right, so this is the measure of angle B. So angle B is 68 degrees. And then the last item I need to solve for to solve this triangle is little b here. So let's go ahead and set up another ratio with our law of sines. I'm going to label my work here. All right, solve for b. All right, so we could use the angle C proportion, or we can use the angle A proportion. I suggest you use the angle A proportion just because it was given. So just in case there was a mistake made here, your next answer won't be wrong also. So I'm just going to go ahead and use angle A here. So sine of angle A divided by side A equals sine of angle B. Oops, not B. Angle B is 68 over little b. So again, I'm going to cross multiply. So b times sine 37 equals 11 times sine 68. And so if I just divide both sides by sine of 37, I'm going to not show that. I'm just going to calculate it in the calculator. All right, so again, parentheses, 11 sine 68 divided by sine 37 is 16.947. So I'm just going to use 16.9 here. All right, so watch the decimal places, all right? But my last side, 16.9. So just as a quick check, guys, just to make sure there were no mistakes made here, the smallest side should be across from the smallest angle, and the largest side should be across from the largest angle. So just spot check that. The smallest angle is angle A. The smallest side is indeed little a. Okay. The biggest angle is angle C, and so the biggest side is indeed little c. All right, so just double check it real quick just to make sure there weren't any blatant errors. Everything checks out, and we solved this triangle because we found the other 3 pieces of information. All right, we found all 6 angles. All 3 angles and all 3 sides. All right, so that's the only one of these 2 I'm going to do because it is fairly simple. They're all going to work out this way. I would like to focus on the side angles because many things can happen here. So let's go ahead and look at one of those. So the directions, always just going to say solve the triangle. So our given this time is little b is 15, little c is 25, and angle B is 63 degrees. So I'm going to go ahead and draw and label accordingly. A, B, C. All right, so little b is across from angle B, and that's 15. Little c is across from angle C, so that's 25. And angle B is 63 degrees. All right, so notice, okay, multiple combinations can be used here for angles A and C. So there could be two different combinations that work, right? But we're stuck here. We could only solve for one thing. The other question we had options, right? This one, we're given the ratio for B. And the only other piece of information is little c. So we are forced to solve for angle C here, right? So I'm going to go ahead and set up that ratio. So sine of 63 divided by 15 equals sine of angle C divided by 25. And so here we still have the same ratio that we can cross multiply, but notice our variable isn't a side, our variable is the angle, right? So we're going to have to solve this for angle C. So the first thing I am going to do is go ahead and cross multiply. So 15 times sine C equals 25 times sine of 63. And then we're going to divide both sides by 15. Okay. I like to show one additional step here. Okay, I like to go ahead and find what this answer is, what this decimal is, because it's very telling, right? So I'm going to do parentheses 25 divided by sine 63. Nope. How about 25 times sine of 63? And then we'll divide that by 15. And so I get 1.485010.874. Okay, and I'm going to write all those down. Now to solve for angle C here, what are we going to do? We're going to inverse sine this, right? So you can type that into the calculator if you want to, but remember what the domain of sine inverse was. The domain of sine inverse is the range of sine. And the range of sine just goes between -1 and 1 because it's the amplitude. And so 1.4 is outside of that sine's range, and therefore sine inverse's domain. So if I were to sine inverse this answer, okay, I'm going to show you how to do that. Just do sine inverse, and then answer, can you see my, no, answer is here above the minus sign in blue. So if you do second negative, it's going to stick the answer in there so you don't have to type all those decimals again. And so it's going to give you an error, okay, domain error, right? And that's because 1.4 is bigger outside of the domain of sine inverse. So this is one of those cases where angle C doesn't exist. Okay, and so if angle C doesn't exist, then this triangle can't have this given information. So this is a zero solution case. Right, zero solution case. The given information is not feasible to build a triangle with. So on the zero solution cases, this will always happen. You'll go and you'll solve for the angle that you're forced to solve for, and then the angle you're forced to solve for will have no solution, right? So angle C doesn't exist, therefore there's no solution. All right, so let's try another one. let's do little a is 44, little b is 62, and angle A is 42 degrees. Okay. So I'm going to go ahead and draw this triangle and label it accordingly. All right, so little a is 44, little b is 62, and angle A is 42 degrees. So again, we're given the proportion for angle A and side A. We're forced to solve for angle B here because we have no information given for angle C or side C. Right? Oh, and a point of interest here, because these are not right triangles, you cannot use Pythagorean theorem, right? You cannot do a squared plus b squared equals c squared, because that only works if you have a right triangle, of which we do not, right? So do not Pythagorean these by any means. So let's go ahead and solve for angle B this time. So I'm going to set up those proportions. So sine of angle A divided by little a equals sine of angle B divided by little b. Okay. I'll go ahead and cross multiply. Divide both sides by 44. And then again, I am going to write that decimal down. All right, so 62 times sine 42 divided by 44. So parentheses, 62 sine 42 divided by 44 is 0.9428. So notice that this decimal will be in the domain of sine inverse. So when we solve for angle B, we will have a solution this time, right? So I'm going to go ahead and sine inverse that decimal. Okay, so sine inverse, pull that answer into the sine inverse, and I'm going to get 70.53, so I'm going to use 70.5. All right, now because we use sine inverse, all right, let me just show you. 70.5 is about here. Okay, so here's angle B. Right? And this angle B has a sine value of 0.94. So that means I don't know what the x is, but I know the y is 0.9428, so on and so forth. Right? So from solving these equations, right, you remember that there's always more than one solution from 0 to 360. There's always two fundamental solutions. So where on the unit circle is the sine value also equal to 0.9428? Right, that's the y value. So over here, right, there's another point on the unit circle that has a sine of 0.9428. And so there's another answer for B here, right? So I'm going to call this B sub 1, and I'm going to call this B sub 2, right? So how do we find B sub 2? Well, these reference angles are the same. So rotated up from the x-axis 70.5 in both directions, right? And so, can you see that? It's getting kind of small on my screen. Right. So if I rotate from the x-axis up 70.5, I'm going to get this angle measure. This other angle is what I wrote has the reference angle equal to 70.5. So if I rotate from the negative x-axis up 70.5, I'm going to get to that B sub 2. all right? So B sub 2 is basically 180 minus 70.5. Did I say that right? 180 minus 70.5. So if I do 180 minus 70.5, I'm going to get 109.5, right? That's my second angle. Right. So the first time we went through, this equation had 0 solutions. Or the equation is going to have 2 solutions. All right. 0 solutions are 2 every single time. You're going to have to try them out. All right. So angle B sub 1, I'm going to call it 70.5, and angle B sub 2 is 100.5. That means I need to draw 2 more triangles up here at the top of my page. Right. So this is going to be like triangle 1, right? And I'm going to label this 70.5. Now I'm going to do triangle 2 here, and I'm going to label angle B the other solution. Right? A, B, C, 109.5, right? So in this second triangle, the given information is still true, okay? Little a is still 44, little b is still 62, angle A is still 42, right? We just have 2 different solutions for angle B. So let me go ahead and label these with the subscripts so we can keep them straight. All right, so in each of these triangles, we have 2 more pieces of information to solve for. We have to solve for angle C sub 1 and C sub 2, and then little c sub 1 and little c sub 2. So we have to solve both of these triangles. All right, so 42 and 70.5, let's figure out what that leaves for C sub 1. I'm not going to show that because I'm running out of room on my paper. 180 minus 42 minus 70.5 leaves 67.5 degrees for C sub 1, right? Let's go ahead and solve for C sub 2. So 180 minus 109.5 minus 42 is 28.5. So there's 28.5 degrees left for C sub 2, right? So now we need to solve for the side C sub 1 and side C sub 2 for each of these triangles. So I'm going to go ahead and set up 2 more law of sine ratios to do that. I am going to use the proportion for angle A and side A because it was given, right, each time. So I'm going to do sine of 42 divided by 44 equals sine 67.5 divided by C sub 1, right? And then we'll go ahead and solve that out. Cross multiply. Divide by sine of 42. Okay, punch that in the calculator, you got your solution. All right, so parentheses. 44 sine 67.5 divided by sine 42 is 60.75. Right? So I'll label that. So triangle 1 is done, right? Now, is it correct? Right? Is the smallest side across from the smallest angle? So the smallest angle is 42. 44 is the smallest side. Is the largest side across from the largest angle? Right? The largest angle is 70.5, and its side 62 is bigger than the other side. Okay, so it did work. The spot check worked out. So I think we're correct there. Right? So let's go ahead and solve for little c sub 2 as well. So I'm going to do sine of 42 divided by 44 equals sine of 28.5 divided by c sub 2. Cross multiply. Divide by sine of 42. I'll just write my answer here. Alright, so 44 sine 28.5 divided by sine 42 is 31.4. So that's little c sub 2. Okay, 31.4. Alright, let's do that spot check. The smallest angle is across from 31.4, which is the smallest side. Right, the largest angle is here. It's across from the largest side. So I do believe we have the correct solution. Right. So here is a side-side angle that has two solutions. Right? Side angle, two solutions. Right? So when we do a side-side angle, we're forced to solve for an angle. And when we're forced to solve for an angle, there are two solutions, unless there's zero solutions. Okay? But you're always going to get one answer from the calculator, and your other answer is on the other side, okay, of the y-axis. And so you do 180 minus 70.5, that gets you your other answer, right? So when we're doing side angles, we're always finding two solutions, unless it's like the first one, when we couldn't even find one solution, right? So this was a side angle with zero solutions. Side angle, zero solutions. All right, so I would like to show you one side angle that has one solution, right? So again, solve the triangle. So we're given little a is 3, little b is 2, and angle A is 40 degrees, right? So side angle. So we're going to do it A, B, and C here. Little a is 3, little b is 2, and angle A is 40 degrees. Right? So we're only given one angle, right, which means there are multiple combinations here for angle B and angle C. Notice we're given one proportion here for angle A and side A, and we are forced to solve for angle B here. So I'm going to go ahead and solve for angle B first. So sine of angle A divided by little a equals sine of angle B divided by little b. So cross multiply. 3 times sine B equals 2 times sine 40. Divide both sides by 3. Right, I'm going to get the decimal here. All right, so 2 times sine 40 divided by 3 is 0.4285. 250,731. All right. So this is in the domain of sine inverse, right? It's between -1 and 1. So if I were to sine inverse both sides, I'm going to get a solution, right? But not only am I going to get a solution, but I'm going to get two solutions. All right, so I'm going to go ahead and label it. B sub 1 will be the solution that we get from our calculator. So sine inverse of that decimal, right, pull the answer in there, is 25.4 degrees. Right? So if one of our solutions, go ahead and explain it again. So 25 degrees is about here. Right? This is where we have some x value, but we know the y value is 0.428525, and so on. So where is the y value the same on the unit circle? Well, that's across here. We're using negative x this time, right? So we know there's another angle out there. Now where is that? Well, if we rotate up 25.54 degrees, we'll get that second angle. Right? So B sub 2 is 180 minus 25.4. And I'm punching that into my calculator, and I'm getting 154.6. Right? So we're always going to get two solutions here when we solve for angle B. The one from the calculator, and then the one on the other side of the y-axis there, 180 minus the answer from the calculator. All right. So let me go ahead and label these. A sub 1, B sub 1, C sub 1. And let's go and label A sub 2, B sub 2, C sub 2. So the first B sub 1 is 25.4. And the second B sub 2 is 154.6, right? So the given information is still true here. So little a is 3, little b is 2, and angle A is 40 degrees, right? So we have two triangles to look at here. Now, when you look at solving for angle C, right, we can do 180 minus these two to get angle C. What happens here, right? Angle A is 40, angle B is 154. If we add those together, we're already at 194 degrees. And that's too many degrees for a triangle, right? So this second triangle does not exist, right? Second triangle does not exist. And so since the second triangle can't exist with the given information, because this angle 40 is given, right, and this was our other solution, this triangle can exist, and so this is one of those only one solution cases. All right, so this is a side angle, one solution. All right, and this is always going to happen. When you find that second angle, is not going to work with your given information. So good news, we only have to find C sub 1 and little c sub 1. Okay, so let's go ahead and find angle C first. 180 minus 40 minus 25.4 is 114.6. Right, little c, we're going to use our law of sines. Okay, so I'm going to go ahead and use the given here and do sine of angle A divided by side A equals sine of angle C divided by little c. Cross multiply. Divide by sine of 40. Plug that in. So, parentheses, 3 sine 114.6 divided by sine 40 is 4.24. So do a little spot check there. Is the smallest angle across from the smallest side? Check. Is the biggest angle across from the biggest side? Check. All right, so I do believe we have the correct solution there. All right. All right, so if you're given a side-side angle, let's go ahead and recap. All right, let me pull this other page up. The first thing that could happen in a side-side angle is you're forced to solve for angle C here. Forced, right? Because we're given B's ratio, we have to solve for C. But when you solve for C, you get a number greater than 1, right? And so when you sine inverse that, your calculator is going to give you a domain error. And so there is no solution. This is the first thing that can happen, right? The second thing that can happen in a side-side angle is you're forced, again, to solve for angle B. Forced, all right? This is the only one you can solve for because we were given this ratio, we were given this number, we weren't given anything for C. So we go through solving for angle B. This one works, right? Because this is between -1 and 1. Now when this one works, that means there's two solutions, right? So the first solution I got from the calculator. The second solution is from subtracting from 180 because they're on opposite sides of the y-axis there, right? 70.5 up from the positive x-axis, 70.5 up from the negative x-axis gives us these two angles. Now in this case, when we plug those two angles in there, they were both viable solutions, right? They both worked with our given information. 42 and 70 still left some room for C sub 1. 42 and 109.5 still left some room for C sub 2. So this is what can happen when you have two solutions, all right? Both solutions that we get here for angle B work with our given information. So on the last example, we have a side-side angle, right? Again, we're forced to solve for angle B. We do so, right? This 0.42 is in the domain of sine inverse, so we get a solution from the calculator, right? The other solution is on the other side of the y-axis, so we subtract 25.4 from 180 to get the other solution, right? But when we put them into our triangles, 25.4 works well with our given of 40, but 154 doesn't work well with our given of angle 40 for angle A. So these are greater than 180 already. So this triangle doesn't exist, right? So therefore we only have one solution. So that's it for 8.2. If you have any questions, please do not hesitate to ask.